let's add and subtract radicals. Before we get into that, though, let's recall what combining like terms is like. So remember, combining like terms, you add or subtract the coefficients on terms that have the same variables with the same exponents. So for this first example, these all have x's, so we can do 3 plus 5 minus 2, which would be 6x. So the x's stay the same. We're just adding or subtracting how many x's we have. If you have multiple variables, just add or subtract the ones that are the same. So 5y goes with 8y, and that would be 13y. 1x goes with negative 5x. 1 minus 5 is negative 4x. So 13y minus 4x. For this last example, we can't actually combine any of these because these are all different variables, so that is just going to stay the way it is. 3x plus 5y minus 4z. Cannot simplify that. So we can do a similar thing with radicals. Notice these are all index of 2. These are all square roots, but the process would work the same with the same index on different radicals as well. So we're going to just add or subtract the coefficients on these like radicals. And notice the number inside is what differentiates these like terms. So here we have a 1 root 3 plus a 6 root 3. So this is going to be 7 square root 3. Okay, so treat the radical part like an x or a y or a z. Like on example B, I can't combine these. 2 root 3 plus 2 root 5, those numbers inside are different, so I can't actually combine these together. Example C, I can do 5 minus 3 is 2 root 2. And on example D, 4 minus 1 is 3 root 5. Okay, so we're just adding or subtracting the coefficients on radicals that have the same radicand, the same number inside. Now, sometimes it might seem like we don't have any like terms, but we can simplify a radical, and that will result in having the same radicand. You'll see what I mean here in a minute. First, this first example, we can actually subtract 10 minus 8 is 2 root 2. Now here on example B, we have square root of 27 minus 5 root 3. And 27 and 3 are not the same. But what I can do with that 27 is think of that as 9 times 3. Right? I do want to get 3 in here because I want it to be the same. And I can actually take the square root of 9, that's 3. So the square root of 27 is just 3 root 3. I'm going to use a different color for this. Is 3 root 3 minus 5 root 3. And now I have like terms, and I get negative 2 square root of 3. So we can simplify our radicals by taking the square root of a large factor of the radicand, which might result in having like terms that we can then simplify again. Example C, these are all root 2, so I'm good to go. 2 plus 6 is 8, minus 3 is 5 square root of 2. Example D, we got 5 root 12 plus 2 root 27. Let's simplify both of these and see what happens. So for the square root of 12, I want to think of a perfect square factor of 12. Now if I think of the factors of 12, 1 and 12, 2 and 6, 3 and 4. 4 is a perfect square. So if I think of this as 4 times 3, that will help me simplify that. With 27, we did this on example B. 9 is a perfect square that goes into 27. So that's 9 times 3. So what this problem becomes, the square root of 12 is 2 root 3. The square root of 27 is 3 root 3. But now I had these numbers out front. This first one had a 5. I'll have to multiply that. This one had a 2. So this problem becomes 10 square root of 3 plus 6 square root of 3. And I can add those together and get 16 square root of 3. Okay, so it is a process, but you can look at a radicand that has a perfect square factor, and you can take the square root of just that part of it. Example E, square root of 4. I can simplify that. That's a 2. Plus the square root of 81 is 9. And 2 plus 9 is 11. Last one here, I have 6 square root of 7 plus the square root of 63. 63 does have a perfect square factor of 9 times 7. And again, I did want a 7 to result there because that's what I had in my first radical. So this problem becomes 6 root 7 plus 3 square root of 7. And I can add 6 plus 3 together and get 9. So it can be possible to add and subtract radicals with different radicands as long as one or both of them can simplify down to be the same by taking the square root of a perfect square factor of that radicand.